Okay, I think we can start. So my name is Holger, and as you can obviously read, I'm talking about energystar. And my talk is divided into 4 main sections. The first one is about energystar itself, a little bit of background information, then about the computer specification of energystar with a focus on laptop computers, and then I will talk about the involved parties, about the advantages, disadvantages, things like that. Then I will come to a section where I will tell you how you can test your laptop for energystar compliance if you ever want to. And finally, I have a short part about the status of energystar in OpenSUSE. So, starting with the background information, Wikipedia says energystar is a United Government program to promote energy-efficient consumer products. And this is basically all you have to know. That summarizes it very well. A little bit of more information. It was founded in 1991 by the EPA, and then later on they partnered with the US government. And you might wonder if energystar is the US only label or something like that. It is not, because of a US government decree, the use and procurement is granted for public authorities. So as a consequence of that, that's, for example, the European Commission caring about the energystar label in Europe. And they have only a subset of the specs of the EPA and have also own specs, but only care about office equipment. But in the end of 2006, they adopted the computer specification, so those specifications are equal. So you might wonder what products can actually be energystar labeled. There's a lot more than just computer product. There are also roofs, windows, things like that, or even dishwashers, clothing washers, boilers, and a lot more. And of course there's the office equipment, like printers, monitors, even exit signs, and of course notebooks or computers, and this will be the focus of the presentation. So, coming to the computer specification, the table of contents look like that. It's about 20 pages long, and it contains a lot more details than I will talk about here. So if unsure or want to know more, consult the original specification. So I have to make clear some terms at first. There are 2 types of laptop categories. Category B are all notebooks that have a video card with at least 128 megabyte of RAM, and this memory has to be non-shared, and all other laptops are summarized in category A. So there are, of course, there are some requirements a laptop has to fulfill in order to meet the spec. It needs 2 important capabilities. It needs a working sleep mode, and in this case it means suspend RAM, and it needs support for wake and alarm. There are also some software requirements. In the default configuration of a laptop, the display needs to power down after 15 minutes automatically, and the whole system needs to power down automatically after 30 minutes. So, for testing a laptop, the specification defines 3 operational modes a laptop has to be tested against. And at first, it's the off mode. It's quite simple. It's just the system is completely powered down and the working state is lost. Then another mode is the sleep mode. That's actually suspend RAM. So the working state is saved to memory. And this is just a low power mode you would usually recover from in a few seconds. These both modes can be extended by another feature, by wake on LAN, and it depends on the distribution channel of the laptop if you have to get the laptop with Wake on LAN enabled or not. Maybe the most important mode is the idle mode, so the system is just fully up and running, and you usually reach this mode with powering up the system and waiting about 15 minutes or a certain time frame until all one-shot tasks are finished and the system is idle. So of course there are some consumption limits for the different modes. On the left side you see the modes. The idle mode is split up into the two categories, and on the bottom you have a scale of watts from about 0 to 25 or something. For an off mode, a system must not consume more than 1 watts, and with Wake on LAN enabled, it must not exceed the limit of 1.7 watts. It's just adding up 0.7 watts to these both modes, so you reach the value. It must not consume more than with Wake on LAN enabled. So I think that's pretty clear. Idle mode, category A laptops must not exceed the limit of 14 watts, and idle mode category B laptops must not exceed the limit of 22 watts. So the specification also defines the requirement, how the test setup might look like, or it has to look like. So the system has to be configured as shipped, so you are not allowed to do any modifications to the configuration. For network connectivity, the live network has to stay in place all the time, and the wireless network has to be turned off. You might wonder why this is the case, because it's a common use case for mobile devices, laptops, to have wireless network enabled, but I'm coming to this problem at a later point. Then furthermore, there must not be connected any external devices to the system. The battery has to be removed, otherwise this would falsify the measurements. And the energystar specification also says if you cannot remove the battery due to hardware limitations, you have to fully load the battery before doing the tests. And of course you need a power meter, which has to be connected between the main outlet and the AC power supply. And this is how the test procedure might look like. It's stripped down, it contains some more details, but I picked the most important ones. The first 4 steps are equal for each test of the different modes. So at first you record the laptop system information, you make sure that it's configured as shipped, you configure the display to power down the display after 1 minute, and as a consequence of this, the idle mode tests will be done with the display switched off. Finally, you shut down the laptop, and now you start one specific test. As an example, I took the idle mode test here. So you switch on your laptop, you log in, then you make sure that the default desktop is in place, you close all windows, things like that. Then you wait a specific time until the system is idle. Then you start your measurements for 5 minutes with 1 reading per second, and then you evaluate your measurements, so you have an average power consumption. And if this sequence was done under laboratory conditions, then you can send the data to energystar, and they will most likely include your product into their database. So that's just another picture just to illustrate how the workflow of the test is. You first prepare the UUT, that's the specification refers to the unit under test as UUT all the time. Then you boot, you write down the system information, then you wait until the idle state is reached, you shut the system down, and then you start one specific test, you wait until it's finished, and then you restart all over again from the idle state. So that's an example how such results might look like. In the top you'll see general system information, then in the middle there are the system capabilities, if it's capable of wake on run, for example, and the bottom there are the actual test results. So coming to the next section, what does you actually get, or what you might get when labeling something with energystar? Of course, the users want to run their battery as long as possible, so this increases the mobility, and they might even save money, not to a huge extent, but maybe a little bit, and maybe they even have a good conscience when doing something good for the environment when buying energystar products. Both manufacturers and distributions, I think their biggest advantage would be marketing, because power management is everywhere these days, so I think that's the most important point for them. And of course, usual companies can reduce the power costs because they have to maintain a lot of systems. So at a first glance, something like energystar is good for everyone. So what have the different parties actually to do to get an energystar certification? The manufacturers, of course, they have to use energy-friendly hardware. They have to ship a good default BIOS configuration, and of course they need a good interface documentation for their hardware features, power management, so that kernel developers can make use of these hardware capabilities. There's a bunch of technologies in the kernel. Just picking some example like power management for USB or VLAN, or something like tickless and Dyntics or frequency scaling. Then there are desktop applications or the desktop developers. They have to lead attention to making the applications configurable so that later on distributions or vendors can ship an energystar compliant default configuration, and they, of course, they shouldn't do something bad like polling every time, and they should make use of new technologies like new default, things like that, to reach events and not to poll every time. So yes, and you of course need a good default policy, something like not running drone jobs on battery and things like that. So coming to the distribution, they actually have the easiest part of the whole stack, but they can also break the whole stack. They just have to ship an energystar compliant default configuration. And you can see from bottom to the top, all parties are involved. And the distributions, if they do not do their job right, they can break the whole stack and can destroy the work of developers, manufacturers, whatever. So that's actually a very important point. energystar is not a hardware-only label. It's a combination between software and hardware. So both parts have to play together in the end to reach to get an energystar certification. So I personally think there are some problems involved in the specification. For example, there are some annoying requirements. For example, the time frame for automatically going to sleep is, I think it's quite short. I fully understand that it makes sense to power down the system when it's not in use, but 30 minutes are quite short, I think. Also, I think there are some missing test scenarios. Like I mentioned before, there are no wireless connectivity tests, which is a common use case for mobile devices. or low usual application tests, like mail browsing, something like that. And also there are all the tests are done without external devices, and I think it's also a common use case that you put in USB sticks and mice to a laptop. So, and as mentioned before, this combination of software and hardware makes it quite hard because all different parties need to cooperate, and well, that's not always easy. So there are currently only a few laptops with energystar label, and even less with Linux, running Linux. A prominent example which is energystar certified is, for example, one laptop per child. You can find it in the product database. So is it accepted? Not yet, I think, in parts in regard to laptops or computers. I personally have seen very less energystar certified laptops. But the vendors and manufacturers start to work on that, and it brings more and more recognition. So now I'm coming to the part where I'm showing how you personally can give it a test and check if your laptop could be energystar compliant. There are two scenarios. The first one a good one, and it's also the one which meets the spec. For this setup you need two computers. One is the unit under test, so the laptop you want to test. And a second, you need a system recording the measurement values, because otherwise, if you would do the tests on the system itself, this would falsify the results of the measurements. Of course, you need an ampere meter. The ampere meter has also to fulfill certain requirements, but I left that out here. Then on the recording system, you need a measurement software. I picked QGTMM. It was the only thing I found which meets all the requirements. And finally, you need a script to evaluate the data from QGTMM. You might wonder where the script and where do you get the script from. I'm coming to that later on. So that is just a picture to illustrate this. You have the one laptop you want to measure on the left side. On the right side you have the recording system with software running, and in between you have the ampere meter. And after doing one test, you can export the data from QGTMM, and you execute the script, and so you get the average power consumption. So that's also the bad scenario, and that's really just for fun if you want to give it a very quick glance. So in this case, you just read the battery drain from a file system, proc, FS or sysfs. So for this setup you have to keep the battery in place and disconnected from power source. And then you need a script for monitoring the battery drain, or you can also use tools like PowerTop, but they already give you, maybe they give you too much overhead already, so it's too, yeah. Of course you can only do idle mode testing, and at the bottom you see an example how you can do it. I just measured for 5 seconds here. So where to find all this information? There's a wiki page on opensuse.org, and it contains a detailed guide how you can measure your laptop. It also has a result sheet template where you can fill out all your values, and you can also find the scripts which are used there. And this is a central point where I will put more and more information in the future. And of course, that's the homepage of the measurement software. So, coming to the last point, is OpenSUSE ready? No, it's not yet, because I still hesitate to push the configuration option to automatically power down system after 30 minutes, and my efforts are quite new, so I think I will try to push this in the near future, but I think some people might have something against this setting.
Yeah.
So I definitely see that it's problematic. So as long there's no applications with energystar compliant default configuration shipped with OpenSUSE, you can go to the build service, and I put energystar compliant K-Power safe and power manager configuration package there. Okay, I think that is it. Are any questions? Yeah, please.
Do you run the test against the laptops automatically, or is it all done manually?
That was done manually.
And do you plan in the future to implement, say, a form or something that makes it run automatically, just bring in your laptop?
Yeah, this could be possible, because you can do remote wake up and things like that. This could be possible to be done automatically. But you have to, the setup with the ampere meter, you have to do it manually.
Okay. And I have a third question. You talked about a database where I can find which laptops were compliant.
Yeah.
Where's the URL?
It's missing from the presentation. It's energystar.gov, so you can have a look. And there it's quite
Put it on the wiki page.
The wiki page has it not yet, but I can put it there.
And everybody can send results to energystar.org or .gov, and they'll take that into account.
I think I'm not sure if you need to be a partner of energystar, so that they will recognize your entry.
So if, for example, OpenSUSE would like to have a list of all registered computers that are known to be energystar compliant, where you can get the label for them if they ship with OpenSUSE, you'd probably first need to have the community send back the results to you, and then you would send it to.
Yeah, I'm not sure if this can be done by the community, but it can. But it really has to meet a lot more requirements to test than here. So the whole setup is quite complicated. So
everybody would get that from large manufacturer willing to.
Or from software vendors from the.
It's currently worth noting there are only 217 laptops shipping within the European Union that are energystar compliant.
Okay.
No, low numbers.
Yeah.
Were the changes you made to K-Power Save just configuration changes?
It's just configuration defaults.
Okay, so we should just put that upstream.
Yeah, maybe.
No, I don't want the systems to go to sleep after 30 minutes. I think that's a stupid requirement.
I guess when you get it, that's actually first installed, there's nothing preventing you from doing it. And you see on the market side that they can ship with a level saying energystar. It might be in the development.
Basically, I think if a hardware vendor, they don't have hardware vendor puts the they want it.
What's the definition of idle? Is playing a movie
No,
considered idle? Or
idle does mean powering up, closing all applications, something like browser, closing it and just doing nothing.
okay.
Yeah, no applications are running. Or it's just maybe you have default applications in the panel, and it's light shift.
Okay. But why not power down then in like 5 minutes? Because there is nothing being done on that machine. It does nothing. There is nobody on the keyboard and it does nothing. There is no program running, hence it can power down. It can go into sleep mode in like 5 minutes because it can wake up from sleep quite fast.
It can, yes.
Why not 5 minutes? Because it's not doing anything.
Yeah, maybe you're running on an IRC client somewhere, so your network goes down. You always.
Sure, but then it's the definition of idle.
Yeah.
If there is a network connection, then it's not idle. It's doing something.
Decided when to put the system into for auto sleep after 30 minutes. What criteria is being used in SUSE?
I didn't get it.
And what basis do you use to decide that the system's idle enough to put it into sleep mode?
How do you decide system is idle?
Well, that's basically in this way. It's done when the X server thinks it's idle. I'm not quite sure how K-PowerSafe thought and GNOME PowerManager got the idle detection, but I think it's X not getting any keyboard or mouse events.
So it doesn't take into account background processes at all?
Yeah.
So playing a video is idle because there is no keyboard input.
No, but it's not a default configuration. The system does not power up and plays a video automatically, usually. If it does, so...
There's probably infrastructure work that needs to be done to refine the idle detection. Maybe have some programs in Hibbin and just say, no, I'm running now, so the system is not idle, even if no video player would be.
So I think time is up. If you have any other questions, I'll be outside at the Susan. Thank you.